Good afternoon. Hello? There is somebody out there. That's good to know. So I'm Paul Steinberg, Senior Vice President of Technology at Motorola Solutions. And I measure my career at Motorola in wireless Gs, and I'm at about 3. So I'll let you work that out. I know what you're thinking. Let's be honest. Great. I'm tired. It's late. I've heard a lot. Here's a boring technology guy. Just what I wanted to hear more about. So anyway, I'll try to be brief and make this as painless as I possibly can. So my topic is build as 5G and wireless technologies, but I'm going to build on a lot of the themes we heard earlier, in particular the point Kara made about software. And so I'm going to talk about 5G and a little bit about 6G, but I'm also going to talk about cloud. I'm going to talk about artificial intelligence, and I'm going to try to bring that together in terms of what it means for critical communications. So first, 5G. 5G, is it an evolution or is it a revolution? It's an evolution. I don't think there's any doubt, although if you look at all the ads we're inundated with on the weekends, they might say something different with all due respects to my carrier friends. What is 5G? It fits all the 10 rules. It's 10x the bandwidth. It is 10x the improvement in terms of efficacy. It is 10x the reduction in cost. And it came in about 10 years. So it checks all those boxes. So the biggest thing it's doing is it's promising enormous amounts of bandwidth, from megabits per second to gigabits per second. How's it doing that? It's doing that by accessing a whole bunch of spectrum. We actually hit the speed of light in terms of information modulation with 4G. The only way you get more through the pipe is to make the pipe bigger. You make the pipe bigger with spectrum. So an analogy. If you think about a water hose or a fluid hose, obviously the bigger the diameter of the hose, the more stuff goes through it. You add more spectrum, you get more through it. The problem or the trade-off is the spectrum that's available is high-band spectrum. It's in the tens to hundreds of gigahertz. So what happens with that is that spectrum doesn't propagate. It doesn't penetrate. It starts to approach Wi-Fi-like behavior. So you get this massively big pipe, massively big hose, but it actually gets much, much shorter. The more spectrum you use up in the bands, the less bandwidth you get. So that's a challenging trade-off. So how are they dealing with this challenge? So technology head of China Telecom actually summarized it best. So first of all, they're saying 5G is expensive from a CapEx point of view. Carriers always say that. The second thing, it is proving to be very challenging to deploy to access that spectrum. Coverage is a problem. So they're needing more cell sites than they thought. Third, the cell sites are actually consuming 3 to 4x the energy of the equivalent 4G site. So that was something I don't think anybody expected. So you put all this together and it's getting costly. So the industry will work through that and it will be okay. The other thing that they said is we haven't found a killer app for it beyond, you guessed it, the internet. That's okay. The internet is a very good killer application that served us well for a long time. What is 6G? 6G looks to be more of the same. It looks to be, let's go to terahertz and let's go to terabits per second. It may be no different. It may be from a range of no more from me than to this front table, but it will still be very, very fast. So looking at immersive technologies, looking at solving the propagation problem by putting repeating technology in things like window frames, so to repeat indoor with outdoor. So solving problems of 5G with 6G is mostly what I hear now. If it plays to form, it'll come in about 10 years, or the end of the decade is when we'll start to see 6G. But the key is, it's being defined now, 10 years before anybody actually even tries to put it into play. Okay, so that's kind of the wireless landscape really quickly. Let's talk a little bit about cloud. So what does cloud have to do with this? So a lot of people think cloud is simply the ability to rent a computer and storage at scale. And it is that, infrastructure as a service. But more importantly, it is the ability to leverage an enormous amount of software. Platform as a service, software as a service. That gives us an enormously complex but enabling leveraged platform to build new stuff on. It's also the ability to deploy and scale and monitor these new applications. So Mark Andreessen said, software is eating the world. Cloud, I would submit to you, is allowing the world to be defined and embodied in that software at scale. The network itself is now being embodied in cloud. The network itself is now software, not appliances. So the interesting symbiosis is the cloud needs the network to move things around. The network needs the cloud to be. So things are different now than the old days when we used to just connect computers with networks. Now there's actually an intricate relationship. Artificial intelligence, we talked a lot about that today. So where does AI fit into it? It will be as pervasive in products as compiling technology is to make the products today. It'll be infused in everything. It will leverage the enormous amounts of data. So Palmer talked a lot about humans not doing a great job at mundane tasks. And oh, by the way, humans tend to be very expensive and not doing a great job. We need AI to solve and sort through all of this data. I've seen estimates that last year as a human race, we created 59 zettabytes of data. So a zettabyte is 1 with 21 zeros after it. So what is that besides a really big number? I saw an estimate of the number of grains of sand on Earth. So imagine every desert and every beach, and imagine you could add up all those grains of sand. It turns out that 1 zettabyte is about 100 times more than that. So we created that much data as a human race last year alone, and of course, like everything else, that's growing exponentially. A lot of that's video, a lot of that is audio and unstructured data. We need the AI to make sense of it. So those are the 3 key ingredients that we have to put together. So if I think about, how does that all fit together? Let me assemble the pieces here just a little bit. So we have the ability to move enormous amounts of content, video, media, whatever the case may be, with high resolution in a mobile environment. That's a good thing. We heard earlier this morning a very powerful message that the importance of video in police reform. So if a picture's worth 1,000 words, I would say a video's worth 1,000,000. And so we can move a ton of it now. The second important thing we can do is we can now position the compute where we need to. 5G brings along this thing called mobile edge compute. It's kind of a solution looking for a problem, but really what it is it allows the cloud to be extended further out. Instead of just a few regions and a few availability zones, extended to the very edge. So that gives us latency opportunities, that gives us different ways to think about efficiency and ways to think about reliability. So we can do that. So now we can use artificial intelligence to watch the video, to listen to the audio, and to find in there what really matters, to surface that in a way that's meaningful. And oh, by the way, we can use AI to look at and listen to electromagnetic spectrum. And it's not just finding where is that person or what is that event that occurred? With machine learning, AI can learn patterns of life. So over time, it understands what is normal. Once it knows normal, it can actually identify abnormal. And that becomes very interesting, especially to security forces. And we can interoperate communications so that we use the best network. And I'll get back to that in just a second. I can submit to you that it's not a world of a network. It's not the 5G network. It's not the 6G network. It is a confluence of networks. Satellite or non-terrestrial networks, purpose-built networks such as tactical radio, land mobile radio, and of course the broadband networks. They all work together to create an answer. And then finally we can take all that and power a workflow to create an outcome that's intelligent, that's guaranteed to be communicated, and it actually gives us the ability to place people in different locations relative to where they would otherwise had to be. A lot can be done remotely now. So what's Motorola's take on all this? So what I've just described to you is, I think of it as not mission-critical communications, which we have done for 90 years or more. It's really now about mission-critical intelligence. And so all those things I spoke of, certainly communication is very important, but it's not the only thing now in the entire stack. And if you also think about this notion of hybrid networks, we just learned an important lesson with Hurricane Ida. It turns out that in the areas of impacted area down south where the hurricane came on shore, FCC reports that about 28% of carrier network sites were down. And not just for a few minutes, for days. 60% of carrier network sites were down in the areas that had to be evacuated. Again, not for minutes, but for days. What first responders have used for a long time, land mobile radio, was unimpacted. It did what it was supposed to do, which was a good thing. So our first responders could communicate, could help people, and help solve problems in a dire need. So the message is, you need to put these together in a meaningful way. FirstNet was mentioned earlier. I look at other countries in the world trying to solve this problem. United Kingdom, South Korea, they've all said, I'm just going to throw away the network that's purpose-built to do this, and I'm going to replace it with a broadband network, either purpose-built or with a carrier network. The UK's been trying to do that for 7 years, and they have still not succeeded. FirstNet, in my humble opinion, is getting it right. They've said, look, broadband is an important enabler. Let that do what it does. Let me bring it to first responders in a meaningful, efficient way that is accretive. Let me not try to displace what they already have. And let me focus on interworking the two so that the two become one. So FirstNet's got it right. I don't know of any place else in the world yet that has quite gotten it correct. So adding software definition to the radio. So the radios need to become flexible. So it's not about what a particular piece of hardware does. It too is an appliance. So we basically have some radio products, part of the DoD 5G consortium that was mentioned earlier, where we have a radio that's the size of a paperback book that can actually modulate, I think, about 20 different waveforms. So yes, 3G, 4G, 5G, GSM, Wi-Fi, tactical radios, land mobile radio. Just change the software in it. That's all you have to do, and it takes a matter of seconds to actually do that. So increasingly defining these capabilities in software. Motorola's invested about $4.5 billion in acquisitions in the last couple of years, in the last 5 years. All those acquisitions were in the area of secure video, video surveillance, mobile video, command center workflows and software, and cybersecurity. So think of this as a stack. The networks allow people to communicate. The action that's important is that workflow on top, and a big part of that is video. And again, that platform has to be consumed by, augmented by artificial intelligence to improve the workflow. Just video alone. It's estimated that by the end of this year, there will be 1 billion video surveillance and security systems deployed, or cameras deployed on the Earth. About half of them in China, the other half actually scattered across. Now, interestingly enough, according to the report I read, the US has more video cameras and more video security cameras deployed per capita than any country on the Earth. So I didn't know that. I would not have guessed that. I would have guessed even China would have won there too, but they have a lot of people, obviously. There will be 45 billion with a B, cameras in the world within about 2 to 3 years. So that's about 7 cameras per person on the planet. Think of all that video. No way in heck can human beings find what matters in that video in the time that they have. That's why our focus on AI and ML. And then finally, cybersecurity. So I had an epiphany. I don't have that often. It doesn't happen often, so maybe it was just something happened one day. But many years ago, land mobile radios, the mission critical networks that have to work always, that businesses bet their businesses on, first responders bet their safety and security on. They have to work. They always have to work. They're engineered in very special ways so that they fail in a very, very, very clever, degraded, but graceful way. And for the longest time, they weren't interesting from a cyber point of view. Who wants to attack one of those? There's no money in there. There's nothing to be had. There's nobody to exploit. They don't really touch the internet. They're pretty small threat surface. But you think about it, as nation state actors and as other people, terrorists got more organized, starting using cyber as an offensive threat, what better way to magnify the impact of what you're doing, whether it be kinetic or whatever else, than by preventing people that need to from calling for help and preventing the people that can help them from communicating with each other. So we went from, in my opinion, not interesting to cyber to ground zero. So we invested very heavily in cybersecurity as well. So in conclusion, I don't think the answer is a technology. I think it's a confluence of technologies. And the vast majority of this is defined in software, increasingly so, even the networks. About all you need that's in hardware is to stick the light in the fiber or to modulate the airwaves. The entire remainder of it is malleable and flexible. So that's first important realization. The second important realization is AI is an imperative. It's not separate, it's all part of the stack, and cloud is an enabler of that. Many countries are trying to figure out now, how do I deploy sovereign cloud? Because there's very few cloud service providers at scale in the world. Google, Microsoft, Amazon are the big ones. And so you see things like in Singapore and in Germany where they're actually doing partnerships. I think it's inevitable that Chinese will try to get into the cloud service provider business because that's the new control point in the technology. Whether they will get in, whether they can, I don't know. Finally, my message is we need help from government in terms of responsible, organized, definitive direction and guidance. So Motorola's grabbed onto some of the surveillance technologies, license plate recognition, facial recognition. Why do we do that? It's very clear to us that there's much more good that can come from that than harm. Is there downside? Of course. If misused? Of course. We don't want the headline Motorola technology used for egregious human rights violations in country X. But we need some guidance from the government in terms of what's okay and what's not. So we have some certainty of where to innovate, how to innovate. We'll build a product responsibly in that regard. So I think the National Security did a report. National Security Council did a piece on AI, which I thought was very, very good. I think candidly the EU is getting it wrong by trying to regulate AI as a standalone entity. So I think innovation, we've talked a lot about that today. It's when oftentimes serendipitously things come together in a way that actually solves an important and impactful problem. So all the things I talked about, I think it's not any one of them, it's all of them together that unlocks the future of the United States, safety and security in the world. So thank you very much.